All right, in the previous video, we covered creating water. So we have our little water simulation here with our flowing water. And today I thought we could cover adding trees just like these. If you break them, you can see that the leaves start to decay. And if you hover over the blocks now, we have these on hovers. But if I click a sapling and I place it on grass, this will randomly grow over a set period of time between its 7 stages until eventually it becomes tree. And there you can see we have a tree. So that's what we're going to be covering today, is the on hovers and the tree growth. So let's go ahead and let's get started. So the first thing I want to do is add in a couple more of these block types, but I'd also like to change how these are being created. So we're just going to replace these with our little on hover thing that we have there. So the way we're going to do this is we're going to take this div with a type of grass and a class of block type. We're going to give it a tooltip class as well. We can then go ahead and close this div. And then inside of this div, we're going to add 2 spans. The first one is going to be the counter span. So it's just going to be the ID for the block type and then dash counter. That'll just have our number in it. And then the other one is going to be a span that has our tooltip ID with a class of tooltip text. And that's just going to have the actual word that shows up when you hover over the block type. So we're going to go through and we're going to do this for all of these, and then we'll add in the types for the wood, the leaves, and the saplings. So let's go ahead, let's replace the dirt, replace the stone, the iron, the diamond, the water, and then after the water, we'll add 3 more. The first one is going to be our wood. So we're just going to replace all of the things that have like water, for example, with the word wood, and then we'll be good to go there. The next one is going to be for our leaf blocks, and then the final one is going to be for our sapling blocks. So we can go ahead and save that, hit F11, and now if we right click on play game and use the open with live server, we should be able to open this on port 5501. And then hopefully, there we go, we have our wood and our leaf and saplings here. So that looks pretty good, but of course we can do a little bit better here. Let's come up to the top and below our style sheet.css, let's add in another style sheet. This one's going to be for tooltips.css. So then we'll right click tooltips.css, hit enter. We can then come into our tooltips here and we can add in a class for the actual tooltip. This is all taken from W3 schools, so it's, you know, questionable quality, but it should be good enough for our purposes. We're just giving this a border bottom. I don't actually know if this is used. Let me just check if I hover. Oh, I can't hover anymore because we switched. So this should be fine though. The next thing we want to do is add in the stuff for the tooltip text. To do that, we just come down here, we tab this over. And then in the tooltip text, which we're grabbing by the tooltip class and then the tooltip text class, we give it a default visibility of hidden and a width of 120 pixels. We then give it a background color of black. You could, of course, change this to whatever you'd like. Maybe here we can make it a gray of 87s. We then give it a text align and we give it some padding. After that, we give it a border radius. Once we have that done, we then need to position it, which we can do by calling position absolute, and then we give it a z index to put it in front of the other stuff. The final thing we need to do is actually show this on hover, and if you'll recall from some of the Rails tutorials we've done on the channel, a on hover is just where you do the class name :hover, and then you can add a second class name if you'd like, but the :hover just tells you that this is a on hover. So whenever you hover over it, it's just going to set the visibility to visible. We'll come back over to our playgame.html and save this just in case, and then I'll refresh. And now if we hover on these, you'll see that nothing's changing. But you can see if you refresh really briefly, there's a tooltip. And the reason why is each frame, it is painting over what the contents of the inventory are. So these are all being reset each frame, but our new blocks aren't. So we can actually see what this needs to look like based on the new blocks, because they aren't being reset to have their 0 inventory updated. But for now, this is good enough. Let's come over to our sketch.js. In our sketch.js, we need to add a couple new block types just in case we need them. We'll just add these in real quick. We're going to have a water, wood, leaf, and sapling. And then in a future video, we're probably going to refactor this into something a bit more object-oriented because right now this is starting to drive me a little bit bonkers going through this. So if we now come down to our containers right below the restart button, we will add 3 more. We'll add one for the wood container with an ID of wood, leaf container with an ID of leaf, and sapling container with an ID of sapling. We can then come down below the containers here, and we need to actually grab the new spans that we have in our HTML page. So we have these counter spans. We now need to grab those below the document IDs. And for this, we're going to do a little bit more copy pasting again. Basically, you can see here, we're just going to grab a grass counter instead of a grass container. We'll do the same document, get element by ID, but then it's going to be for our counter element IDs. So we have our grass counter, dirt counter, stone counter, etc. You're just going to go through and grab all of those. Once that's done, I haven't added a counter for the amount of stuff to collect for these, but if you want a win condition, you could add it for collecting wood or leaves or saplings. The next thing we have to do is actually give these things some color. So if we look at our buttons right now, they don't have any color. So let's go ahead and let's add some CSS for our buttons. To do that, we can come into the style.css and come down to the bottom. And in here, I have a couple different colors we can use. So for our wood, I went with this weird brown color of 91, 45, and 0. Our leaf is a RGBA, which it has a 5, a 131, a 5 right here, and then a 0.5. And then our background color for our sapling is a 191, a 199, and a 49. And actually, I don't think this needs to be an RGBA. That was just a remnant of what I was doing. But if we refresh, we can now see that we have a wood, leaf, and sapling color. So that just about handles all of the style.css stuff. We now need to take these and copy them into our sketch.js. So just like before, we're going to have different colors that we're going to need to use in here. We're going to have a leaf color. This is 5, 131, 5, and then 127.5 is just halfway to 100 or 255. So this is a opacity of 50. So it's going to be a little bit transparent. We can then do a sapling color of 191, 199, 49, just like the other one. And actually I missed it, but we do need the wood color. So let's put that above the leaf. Our wood color is just going to be 91, 45, and 0. We can then go ahead and save that. Next thing we need to do is come down to where our player added masses are, and we're just going to add another array, this one to keep track of our saplings. We're just going to push into this when we have a sapling and then slice out the sapling when we're done with it. We can then add a wood counter. We'll give ourselves 30 wood, a leaf counter. We can give ourselves 60 leaves, and a sapling counter where we'll just give ourselves 5 saplings. We can go ahead and save that. And now we come down to our setup function. So what we can do is we can set up our new block types, and then we can go through all of the setup stages. So for now, let's just go through here and set up all of the block types that we need to add everywhere. So one quick fix that we're going to need here is to draw the sky below our whatever block type we're drawing, just so that we have the background there. Just makes the transparent blocks look a little bit more transparent if you do it that way, and it stops the transparent blocks from just continually adding their color until they're all fully opaque. Once we have that, we then need to come down to our event listeners and again prove why object-oriented programming is a good thing. Here we're going to add a wood container, which is just going to be our event listener. So whenever we click on it, we can select the wood blocks. It'll work just like the rest, just replace it with wood instead of water. Here it's going to be leaf instead of wood. And the last one, you're just going to add sapling instead of leaf. And that'll give us our on-click listeners. We can then come down here and we need to add something to our node real quick, which is just going to be our growth stage, which we'll just set to 0. We're only really using this for the trees right now, but we might have others in the future. And we can always reset it to 0 if we're not using it. So it's just a quick thing to add in and it doesn't have too much overhead. Next thing is down here, we need to add it to our, where is it? Player inventory, I think, right here. we need to add a case for the wood. And then we just do player inventory wood ++ with a break. We then need a case for the leaf, which is going to be the same thing with a break. And then we need a case for the sapling, which is going to be the same thing with a break. We can come into our set and draw block type stuff. And in here, what we're going to do is after the if statement where we check if it's a water block type, we can just do a else if this is a block type equal to sapling. And in here, we're just going to do a saplings.push for the node. At the end here, after everything else, we just set the growth stage to 0, because if we've placed a block, we don't want it to have a growth stage. It should start at 0. Of course, if you did something fancy, I don't know, like plotted plants, you might want to change this so you could place something that has a growth stage. But here, we're just doing a pretty basic game with just some basic functionality. So the next thing we're going to do is add to our block colors, where we just add a case for wood, leaf, and sapling, where we just return those colors when we try to select based on block type. In our check for the player having enough resources, you already know what we're going to have to do. We're going to come below water. We're just going to paste in a wood, a leaf, and a sapling check. Okay, while going back through things, I realized that I missed something down here. So what we're going to do, you'll see this broken for the rest of the video, but just trust me on this. We need to change these grass containers and all these containers. We are now setting the counters instead of the containers. So we'll just change all of these to be the word counter, which we can do by just holding Alt, clicking on some of these. It looks like I changed the counters here, but I didn't change the counters for the older types. So we can just change this and make it the word counter. And that will fix this. And then the other thing that I need to cover again, because I went back a little bit too far, is right down here. We're just going to add in the case for the wood, the leaf, and the sapling. I'm going to hit F11 now, and I'm going to try to place some wood. That seems to work. I'm going to place a leaf. That seems to work. And I'm going to place a sapling. That also seems to work. So that seems fine. And of course, the water interacts with them just fine too. So that's also good. And I can't walk through them. So that seems fine. Next thing we want to do is come into our constants.js, and we can actually get started on the tree stuff. So the first thing we're going to do below the min flow, we're going to give it the tree some growth stages. I'm going to give it 7. So it'll start at 0, go up to 7. Once it's 7, it becomes a tree. I'm going to give it a growth rate. This is going to be out of 100. So this is a 10% chance to grow. And then I'm going to give it a plant rate, which is also going to be 10. This is just going to be how frequently we place trees when we spawn them initially. So the growth rate affects the actual growth of the sapling. The tree plant rate affects the number of trees you see in the world. Next thing we have is a leaf decay rate. Again, all of these are out of 100, and this is just a 10% chance for a leaf to decay. We then have the number of blocks to check for a wood block to see if a leaf needs to decay. We can then convert this into leaf wood range in blocks, which is just our leaf wood range times our block size, which gives us our 4 blocks. And then the last thing we have, again, out of 100, is just a 8% chance to drop a sapling. Once we have all of that, we are actually done in our constants, I believe. The next thing we can do is come over to our block.js. There's really nothing too fancy in here that we have to do. It's just going to be one function. We can add a comment for it right here, which just says we start at y = 0 and move down until a non-empty block is found. This is going to, GitHub Copilot is the thing that generated this to begin with, but I don't really care for how it does its for loop. So instead, we're going to do a for let y = 0, y is less than height, y plus equals block size. We're going to find a node, which we can call from up here with our find node function. We can then say if this node dot block type does not equal sky, then we want to we want to return the node. So we're just finding the first node that is not a sky node, and then we can end this. If we don't find anything, then we return null, and then we can do our null check outside of this. So that is our helper function in the block class, or in the block file. I wish it was a class, but I didn't make good choices growing up. Okay, so let's come back over to the sketch.js. And in here, let's now get started on our tree logic. So the tree logic is actually not that complicated. A lot of it is just the initial setup, which I know can be said for a lot of things. But basically, we're going to do our terrain generation, and then we're going to do some tree generation. So it's just going to be another function that we call called generate trees. And then once we have our trees generated, we then need to do a check in our draw function. Before the draw terrain, we just say do the growth stages. Once we have that, we can then move down a bit and we can implement this do growth stages function. So we'll start right here, right above draw terrain, where we say function do growth stages. In this do growth stages function, we want to start by looping through all of the things in our saplings list. Our saplings are just going to be different nodes, which means we can then grab the stuff out of the node as needed. So we're going to grab the X, the Y, and the growth stage from the node itself. We then check what the growth stage is. So we say if the growth stage is less than the tree growth stages, so that means it has more to grow, and random of 100 is less than the tree growth rate, wherever that is, right here. So if we have more to grow and we get lucky and we hit that % chance that we need, we then want to do saplings.growthStage++. Else if we check the growth stage, if the growth stage is greater than or equal to the tree growth stages. Now it should only be equal to the tree growth stages, but it never hurts to be extra certain. If we get to this point, we then need to create a tree. So we're going to create a function called create tree, and we're going to give it the X and Y where we want to start the tree. After we create a tree, we then need to remove the tree from our saplings list. So now that we have that, we can implement our create tree function. So we'll come below the growth stages and we'll just implement a tree growth function. This tree growth function is going to start by getting a random tree height. In my case, I set it to between 3 and 6, but you can change this as needed. And then I just multiply this by the block size. Once we have that, we then create a for loop. This for loop is just going from I equals 0 to the tree height. And then we just check if I is less than the tree height, in which case we need to let the node equal, and it's going to say plus I, but it actually needs to be minus I because Y increases as you go down. So we have to subtract to go up. We then say, okay, we find a node. Now let's set and draw the block type for the node to be the wood type. If I is greater than 2 times the block size, we then want to create some leaves. We then also have to implement this create leaves function, which we can do right here. Oops, right here. And then we can close this. In the create leaves function, we just do 2 quick declarations. We say the number of leaves on the left side of the trunk should be a random integer between 0 and 3. And then multiply that by the block size so that we get 0 to 3 blocks, or I guess 0 to 2 blocks because the 0 is inclusive and the 3 is exclusive. We do the same thing for the right, just so we get a bit of variation. We can then say, all right, let j equal negative number of leaves to the left, while j is less than or equal the positive number of leaves to the right. So this might be negative 3 to, or this might be 3 and 3. So this would be negative 3 to 3. So you're going to have 3 blocks on the left, 0 is going to be a log, and then 3 blocks on the right, and then you say j plus equals the block size. Okay, so now that we have that, we want to grab the potential node to place a leaf. So we say let the leaf candidate node equal find the node at x plus j and y minus I. So I is being passed in from here, which is just going to be wherever we are in our loop going up the tree and generating the leaves on the left and the right. So we subtract I because we're trying to go up the tree. We then have x plus j, and j can start as a negative number, which will move us to the left, and go up to a positive number, which will move us to the right. We then have to do one quick check, which probably will explain a little bit. But we have to make sure that the leaf candidate node is not a wood node, because if it is, then we would be getting rid of the wood blocks. We don't want to get rid of the wood blocks. We only want to place leaves next to them. If we don't have a wood block there, then we're good to place a leaf node. And that's it for our create leaves function. We can then come outside of our loops here. We actually need to close this. But we can come outside of our loops here, and outside of this last one, we can set a canopy height. This canopy height is actually where we do our leaves on top of the tree. I got this a bit confused. This is for our left and right. This one here is going to be for our creating the leaves on the top of the tree. And we just use the same function. We start at the canopy height, which is the tree minus 2 times the block size. So again, -2 is above the tree. And then we go down to the tree height by doing I plus equals the block size. And then if we do that, well, nothing's going to happen right now because we have more to implement. But hopefully this will make sense as we continue to implement these functions. But basically now we have to come down to our draw terrain. In our draw terrain, at the start of our little loop here, we then want to say, all right, if the node's block type is a leaf, we need to do the leaf decay. Now the leaf decay is its own little monster of a function. We can do it right here. We'll say function, do leaf decay for this node. And what we need to do is we need to grab the X and the Y for the node. We then need to check and see if there is any wood in range. So we'll create a Boolean, set it to false by default. If this is true, then that means we found a wooden log and we don't need to decay our leaves. Next, we need to create a for loop. We're going to say for let I equal, and then in our constants, we have that obnoxious name, the leaf wood range in blocks. We're going to say let I equal negative leaf wood range in blocks. We're going to say while I is less than or equal to the leaf wood range in blocks, we want to do I plus equals the block size. And yes, that is a very disgusting for loop, but it does what we need it to. Unfortunately, it only does it in one dimension. So now let's add in the second one by saying let J equal the leaf wood range in blocks. J is less than, J is less than. Now what we can do is we can try to find this leaf. So we just say let node equal find node, X plus I, Y plus J. And then we just do a check. If this node is of type wood, then it means that this leaf block has wood in range, so we can't decay it. And actually this shouldn't be break, this should just be return, because we don't need to be here if we found something. However, if we haven't found something, then it's time to decay. So then we should do a decay leaf, and we can pass in the node. And we'll come right here and we'll do a function to decay leaf with a node. And then in this node, we just want to do a random, where we do random of 100 less than leaf decay, which is that constant we declared earlier. If this is true, we then need to set the block type to sky. We do this. I don't know if this is something you want to do, but in my case, I add the leaf to the player inventory just so that there's a bit more going on. We then say, let the drop sapling chance, or should we drop a sapling equal random of 100 less than sapling rate. And then we just check if we should drop a sapling, then we add a block type to inventory for the sapling. Okay, so if we save that, come over here and refresh and hit Control-Shift-I, you can see that generate trees is not a defined function on line 94. So if we come up here and we check for generate trees right here, we declared this, but we never used it. For now, we're going to just go ahead and comment this out because we want to test some stuff. So if I place a leaf block all over the place, you can see them start to disappear. So that's good. We can place a wood block with a leaf block next to it. That seems to work. If we just start placing these out, you can see that after we get, it looks like 4 blocks away, we start to have some leaf decay. Of course, I can't really check on the up direction, but we can check on the down direction. So it seems to be about 4 in every direction. Okay, and then if we come over here and we just place a tree, we can see if we can grow a tree. Because we have the logic to make the tree go up, which it looks like they do. We have the logic to create some leaves, which don't look great, but it's good enough for the sake of this. Now let's try to break this tree and see what happens. So we're getting leaf blocks as we break it, and we're getting a couple saplings as we break it as well. So if we break all of these, we'll see if we get more than 5. It looks like we only got 4 that time, but we have the logic to break and place trees, and they decay the leaves as we are breaking all of the logs. Real quick, I almost forgot. The last thing I want to do is come down to our mine block method here. And inside of this function, I guess I should say, we just want to check and see if our block type is of type sapling. If it is, we then want to grab the index of this sapling by calling saplings.indexOf for this node. And then we want to say saplings.splice to get this sapling out of here. Once that's done, we can go ahead and save this and we should be good to go. So that's good. Now let's do the generate trees function. So we can come in here. Actually, let's test this a bit more. Let's make sure we can place a sapling in water. The issue with that is we can also place a sapling on rocks, and I only want them to work on grass. So let's go ahead and let's add in these restrictions real quick. Basically what we need to do when we try to place a tree, which is going to happen way down low, is we need to check if we can actually place a block. So this happens in the place block function right here. What we do at the start is we just do a check and say, hey, have we failed to place a block? If you don't have this, what'll happen is you can create logic to stop yourself from planting a sapling. But if you try to plant a sapling here and it doesn't plant, it will still get subtracted from your inventory. So this is just a check to make sure that we're not subtracting from our inventory if we shouldn't be. So we can come down here, we can create this function real quick. Say function, failed to place block. It takes in a node and the prospective block type because we haven't set the block type yet. So what we want to do is just check if the block type is of type sapling, in which case we can fail to place. If it's of type sapling, we then want to do a node below where we find the node below this one by doing node.y plus the block size. Again, every time we go down, we have to add. It's a little bit backwards, but it's unfortunate reality of using this canvas thing. We can then come down here. We say if the node below dot block type does not equal grass, return true, in which case it is true that we have failed to place a block, which means we need to return and not subtract it from the inventory or draw the block. However, if we've made it to the end here, we can then return false because we have successfully placed all of the blocks that we've checked for. In this case, we're only checking the sapling, but we might add more in the future, in which case we already have the logic for this. Now that we have that, we can come in here. We can try to place a sapling on this dirt here. Doesn't work. This rock here doesn't work. This water seems to be fine. What we can do is break some of this grass. We can place this grass right here, drop some water down, and try to place a sapling right here. That still works, which is fine. Totally okay with that. I just don't want to be able to place it on the dirt, rocks, or anything else. So now we are placing this as appropriate. What we can do now is we can work on the logic for actually doing the placement of the trees. We can come up to the top where we have our generate trees function. We grab this generate trees function, and we just want to do this right above the, the paint terrain tiles right here. So we have our generate terrain. I then want to do function generate trees. We don't need to pass anything in. In our generate trees, what we want to do is we want to iterate through all of our x's. So we say for let x equal 0, x is less than width, x plus equals block size. We then say let the node equal, and then we use that helper we created earlier in the block.js, this find first non-empty node. We do this, we then have to pass in an x because we're only going left to right, so we only pass in the x, and then it'll handle the y from the top to the bottom. If we get back a null result, we then want to return. So if node equals null, we return. We didn't find anything. We'll just do that as a little guard clause. Then we can check if the node.block type is equal to grass. And Oops, and our random of 100, and I'll scroll down so you can see this. If our random of 100 is less than or equal to our tree underscore plant underscore rate, then in that case, we want to say let the node above us, because we are on the grass block, because this is our grass node. We want the node above the grass node to be set to the tree. So we create a tree on that node above the grass node, just like that. We can then save this, come over here, and now we get some trees when we refresh. I can full screen this, refresh, and we get a couple trees. And depending on what the seed is, we get extra special trees. I can change this to 1337 so we can have the same seed. And you can see here our water is getting trapped on the leaves. But everything else seems to be working just fine. We can still draw our water, and we can go and chop down some trees to get some wood and get some saplings if we so desire. Every once in a while we get a sapling. You could even change the leaf decay to have a chance to give you some leaves, as opposed to just always giving you leaves. But I think this is fine for now. Let's finally just go ahead and try to plant a few saplings on our own just to see what happens. And you can see that over time they do get placed, and it takes them a little bit to grow, but that's ultimately up to you. I think for me, this is good enough for now, because we could always implement a better system in an actual game engine. But yeah, that's going to do it for procedurally placing trees depending on your seed. Hopefully this was helpful, and hopefully I'll see you in the next video.